be seeing ER model. ER model, the basic model which is used in DBMS to represent a database, or it's nothing but called as a conceptual design of a database. Okay, so basic content. What we'll be seeing today is the first is the basic concept, that is nothing but basic components and features of ER model and how they are represented and few examples of it. Next, what is ER model, or what is basically abbreviation of ER model? ER model, nothing but it stands for entity relationship model. This model is used to define the data elements and the relationship, the basic data elements and the relationship for a specified system. Okay? And as I've already said, it develops a conceptual design for a database. Okay, that is nothing but it develops a very much simple design and easy design to view of a data. That is nothing but a design to view a data. And how is that? We'll see in upcoming classes. Next, let us see an example here. Suppose we have a student. Okay? We have a student where student we represent in rectangular form because we call it has an entity. Any entity in database is represented in the form of a rectangle in ER diagram. Whereas the attributes of that entity. Now what do you mean by attributes? Suppose you have a student. Now a student with respect to a university, what can be its characteristics? Attributes basically, what can be the characteristics of a student? Whenever suppose a student is enrolling in a university or a college, what are the basic things which he fills on the form? That is his name, his parents' name, his Aadhaar card ID, if he has a scholarship ID, his age, not his age is, age also, or date of birth, okay, so on. So those are nothing but are called as attributes. Next we'll go to the basic components of ER diagram. Now this ER model is having entities. Now I've said you entity is nothing but an object basically. It can be a student, it can be a table, it can be a chair, okay, anything. Then we have attributes, that is nothing but characteristics of those entities. Now these attributes are nothing but are of four types. That is key attribute, composite attribute, multi-valued attribute, and derived attribute. Next is relation. Now, in a database, you can have more than one entities, right? And these entities are connected to each other. Suppose let me take a student has enrolled in a course. So there is a relationship between a student and a course, and we define this relationship with help of relationship sets, and it can be of one-to-one relationship, one-to-many relationship, many-to-one, and many-to-many. Now this all in detail we'll be seeing in features and components. Next, first we'll see what is entity. Okay, now entity is basically any object, any class, any person, any name. Let me take an example of an organization when employee works for a particular department. Okay, now when an employee works for a department, now can you see this and can you listen to the sentence what I'm saying? Once again I'll repeat it. Employee works for a department. Okay, now this employee and department are nothing but entities. That's what you represent an entity as a rectangle. Okay, so here you have employee and department represented in rectangular form. Now, once again, let us come back to the sentence which I've said. Employee works for the department. Now, works for is the relationship between employee and the department. Okay. Now, let me take one more example where student enrolls in course. student enrolls in course. Now, what are the entities here? Your entities are nothing but student and course. And what is the relationship among them? Enrolls. So I hope you all have understood what is entity. Now, what is weak entity? Now, weak entity is an entity basically which depends upon the other entity. In a common technical term, what it says as an entity which depends upon other entity is called as weak entity. Now, what do you mean by let me take an example for you. Okay, before that, the weak entity is represented by double rectangle. That's what you are saying, a double rectangle. Now, suppose, let me give you an example. You, there's an employee. Okay. Previously, we have seen employee works for or works in the department. Okay. Now, since he's working in a department, he'll be he'll be applying for some LIC, or you called it as he'll be having some dependents. Okay. Now, these dependents are also have some LIC. Okay, based on those dependents are having some LICs. Okay, now this dependent can be the child, the wife, the parents. Now these are nothing but what I'm saying you, what the sentence I'm saying you, dependents. An employer having some dependents. That is nothing but the family members of that employee are dependent on that particular entity. So the family members can be a wife. Now, wife becomes an entity where it is dependent on the dependent on the employee. Okay, so wife becomes an weak entity, whereas employee becomes an strong entity. That's what a weak entity is represented in double rectangle. Here, here they are saying the example of loan entity and installment entity. Now, why installment entity is a weak entity here? Because the based on the loan which a particular customer has taken, based on that loan, the installments he has to pay. Because suppose we have the limit of 20 lakhs. For 20 lakhs per month, based on how many years the customer will be paying, installment is decided. Okay, based on the loan he has taken. If it is 30 lakhs, it will change. If it is 40 lakhs, it will change. Okay, that's what installment is dependent on the loan. Next is attribute. Now, what is an attribute? Now, I've already said you it is either a characteristics or basically it is used to describe an entity. Okay, and it is represented in ellipse form. Now, I have said you student can have a student is having few properties or characteristics. Student can have a student ID, he has a phone number, he has some name, and after that student will be having his Aadhaar card ID, voter card ID, right? So those are all his properties or characteristics, and we can represent them in ellipse form. Sorry, here it is in circular form. Kindly consider it as ellipse form. Next is key attribute. Now, when I say key attribute, it basically represents the what is the main characteristic of a student. How do you identify a student? Okay. Suppose in a database, I'm storing a student related data. Okay. So in that, I want to retrieve a student's detail. Okay. So there are n number of students. In that, each student will be having some name, some ID, phone number, name, age, anything. Okay. Now, how can I get the detail of a particular student with these from these attributes? Suppose I have a phone number. Okay. With phone number, can I identify? Because you can have a number of phone numbers. Can I identify? Yes, I can identify, but it will be difficult to identify with the help of a phone number. Next, name? No. Why? Because a student, you can have n number of students with same name. And age? That also no. Why? Because you can have n number of students with same age. But student ID is always unique. Student ID is always unique. So here student ID is represented as primary keys, where whenever I say a primary key, a primary key, okay, of any entity, then this primary key cannot be null and it cannot be duplicated. That is by default, it should be unique. Every time you insert a student ID, it should be unique in the table and it cannot be null. Okay, and how do we represent it? It is an ellipse with underline. Next is composite attributes. Okay, now we have seen previously we have seen a student is having name, and now this name can again have first name, middle name and last name. That's what we are saying. The student has a name where this name now can have first name, middle name and last name. That is nothing but a name, a name can again be composed of some other attributes, that is first name, middle name, last name. That's what it is called as composite attribute, because an attribute is again distributed in n number of attributes. Okay, or an attribute which can be divided into n number of attributes. Such attribute is called as composite attributes, and you represent them in normal ellipse form. Next is multi-valued attribute. Now, I've said that student is also having phone numbers, and a student can have more than one phone number. Now, such attribute is called has multi-valued attribute, and it is represented in double ellipse or double oval shape. Next is derived attribute. Now, you have student here as entity. The characteristics are name, birth date and roll number. Okay, now you can see if I have a birth date, from the birth date of the student I can get his age. Now, since I can get his age from his birth date, this age attribute is called as derived attributes, because we can derive the age of a student with help of his birth date, and this age is represented in dashed ellipse. Okay, and such attribute is called as derived attributes, because it is derived from other attribute. Age is derived from your date of birth. If a date of birth of student is given, you can derive the age easily. Next is relationship. Now, when I've explained to you about entity, I have said a bit about relationship. So I'll go in detail what is actually relationship. Now, relationship is nothing but it's a relation between two entities. Now, suppose you have an employee, you have a department. Now, what is the relationship between employee and department? Where employee works at or works in a department. Okay. Now, this the works at is nothing but a relationship. That is nothing but it has association between two entities. Okay. Now, suppose let me give you one more example where student has enrolled for a course. So you will be having two entities. One is student, one is course. And what is the relationship in between them? It is enrolls. Next is relationship set. A set of relations which are of similar type is called as relationship set. Like entities, a relationship two can have attributes. Now we are speaking, there is a relationship between employee and department, that is work set. And when we say it and that relationship is nothing but called as relationship set. A set of relationships, a set of relationships altogether is called as set of relationships. Okay, now these relationships can also have attributes. These relationships can also have attributes, and those attributes are nothing but called as descriptive attribute. Okay, those attributes are nothing but called as descriptive attributes. I'm sorry, it should come in with descriptive attributes. And why is that? Because these attributes describe, okay, the attribute which is connected to the relationship. That particular attribute describes the words. describes the relationship. Now suppose what can be descriptive attribute? The employee works at department. The employee works since. Your descriptive attribute can be since. Okay, the employee works uh, works, and what will be attribute here? Descriptive since in that particular department. Next is degree of relationship. Now, when I say degree of relationship, here we check the number of participating entities in a relationship. Now, you can have, and in an entity, you can have more than one participation. Suppose, let me take an example and see. Okay. Now, suppose we are checking here cardinality. Now, basically, what does cardinality mean? Means it defines the number of entities in one entity set. Number of entities in a one entity set, which can be associated with number of entities of other set via relationship. Now, basically, what it means? It defines a number of entities, the number of entities available, the number of entities available in a set. Okay, number of entities in an entity set which is associated with other entities in other entity set. Okay, that is nothing but called as cardinality. Now when do they say it is one to one mapping? Okay, it is one to one. That is nothing but when one entity from set A, there's a set A, set B, one entity from set A is associated with one entity of other set, then we say it has one to one mapping. Okay, when do we say it as? When one set is one entity of one entity set. Okay, one entity of entity set A is associated with, okay, is associated with other entity of entity set B. Okay, and vice versa, then it is called as one to one. Okay, next, one to many. Now what does this mean? One entity of entity set A is associated with more than one entity of other entity of entity set B. Now what does that mean? That means this entity in set A is associated with two different entities of set B. Then it is called as one to many. Whereas if we go from B to 1, then these two entity sets is associated with one entity in A set A. Okay, that means that it can be associated with at most one. Okay, from B, if the entities in B is wants to map entities in set A, then it can map to at most one. Whereas in one, it can map or have a association with more than one entities in set B. Next is many to one. Now we can say many to one, that is nothing but opposite of one to many. Here what happens? Here only one entity set of set A can be associated with one entity of set B, whereas one entity of set B can be associated with more than one entity of set A. Next is many to many. Now what do you mean by many to many? And particular entity in set A can be associated with more than one entity of set B, and same with set B, that is vice versa also is same. One entity of set B can be associated with more than one entity of set A. These are nothing but called as mapping cardinality. Now, how all these components are represented in ER diagram? That is nothing but how are we using them in ER diagram? We'll see in detail. First is ER diagram representation. Okay, we have spoken entity, and that entity is represented in rectangular form. That's what student, you have teacher, you have projects. Since they are objects or real-time objects, we have represented them in rectangular form. Next is attributes. Now attributes, we have said it is either a characteristic or what we call it as properties of a student. So if a student is an entity which has attributes roll number, name, and birth date or date of birth. Next is composite attribute. Now let us see here. We have said that composite attribute is nothing but one attribute is again divided into other attributes. So student has a roll number, birth date, and name. And this name can again be divided into first name. You can have even middle name and last name. That is nothing but composite attribute. Next is multi-valued attribute. Now we have seen that a student is having a composite attribute and other attributes, and also something called as multi-valued attribute. Now what do you mean by multi-valued attribute? That is nothing but a student can have more than 4 numbers. Okay, that's what is represented in double ellipse. Next is derived attribute. Now as I have said in components, that a student is having an attribute date of birth or birth date. From this birth date, I can derive the age of a student. So age becomes now age becomes a derived attribute because it has been derived from birth date. Next is relationship. In relationship, we have seen the cardinalities. Okay, here we'll see how we are representing them. Now, whenever there is one-to-one relationship between two entities, okay, then we represent it as 1 and 1. Okay, two entities, the representation is 1:1 and the relationship. Next is one-to-many. Now, whenever there is one-to-many, okay, let me explain here. Now, suppose here you have student enrolls a course. Now, what does this mean? When I say one-to-one, student enrolls in course. Now, that means only one course is associated with each student. That is nothing but each student can have one course. Only one course, not more than one. Now, here, same thing. We are saying one-to-many. So the same example will take. You have a student, you have courses. Okay, student enrolls in courses. Now when I say 1 to n, that means a single student can enroll in n number of courses. Okay, here this specifies a single student, one student can enroll in n number of courses. Okay. Now, here when I say many to 1, that is nothing but n to 1. It is represented n to 1. So what happens here? N number of students enroll in only one course. So here what happens? A university is providing only one course. Okay, one course. It is, suppose let me take, it's a degree course or it's a degree program. Let me take a degree program, any degree program or undergraduate program. That's a single course. Okay, that's a single course where a student and n number of students enroll in that single one course. Next is many to many. Now suppose you have a student, you have courses. Here we have seen a single course. It can be a degree. Suppose if I'm saying undergraduate course, that if I say CSE department, Computer Science of Engineering department. So yes, you have Computer Science of Engineering department, which is providing a single course. Okay, or you can say it is providing, since we are seeing DBMS, it is providing data management course. So n number of students can enroll only in database management course, whereas here n number of students can enroll in n number of courses. Now suppose there are n number of courses. Suppose there are in courses you have DBMS, you have OS, you have computer networks, you have data analysis, n number of courses. So n number of students can enroll in n number of courses. Now next is participation constraint. Now, when do we say an particular entity is totally participating in a relation or partially participating in a relation? Okay. Now, when a particular entity is totally involved in this relation. Now, suppose let me take this example. Okay. Here. Yeah. What I have said here, a student, a, one student can enroll only in one course. Okay, that means that course is compulsory related with this particular relationship. That course has to be there. That course is compulsory. Okay, that means that course will have a student for compulsory. Okay, so this course is nothing but a total participation. Here, this is the best example where you have n number of students, where the course is nothing but a total participation. Or let me take one more example. Suppose each and every employee, suppose let me take the statement, each and every employee, where employee is an entity, you have one more department entity. Sorry, department entity here, employee entity here. Now this employee works in a department. Now let me give a condition there, one more condition, that a department must have at least one employee. A department must have at least one employee. Now, what I'm making the sentence, that department must have at least one employee. Now, what happens here when I say at least must one employee? Here, department will be having total participation because it should have at least one employee. That condition is there. So, department has to play a role. Okay, that's what we say it as total participation, where I don't give any condition for an employee that it has to work. This employee has to work in some department. I'm not giving that condition, but I'm giving a condition where department must have at least one employee. Okay, where you can have an employee without any department, but an department should have at least one employee. So here, the employee is partial participation, whereas entity, that is nothing but department, is total participation. Next is generalization. Now, what do you mean by generalization? Now, suppose, let us see this example. You have pigeon, sparrow, dove, or you can also take it as women, men, or children. These are all nothing but, these are all a human. Whereas here, if you say pigeon, sparrow, dove, these are nothing but birds. So, generalization of all these different types of species is nothing but birds. Same thing for human, women, men, or some children. There are all nothing but human. So that is nothing but called as generalization. Next is specialization. Now, as I've said, a human is a generalization of women and men. Okay. Now let me see this. Let us see this example. You have a person, okay, which is a student or a teacher. Okay, a person can be a student or a teacher. Now, this specialization basically means this particular person is divided into subgroups, that is student and teacher. Okay, so the characteristics of a person comes into student as well as teacher, and with that a student can have some special characteristics also. Next is inheritance. Inheritance is nothing but combination of both generalization and specialization. Now here you are saying you have name, age, gender, attributes of a person. This person can be divided into subgroups, that is student and teacher. So these characteristics, that is name, age, gender, these characteristics of a person, okay, is taken by student, where the student can also have some special characteristics, that is roll number. Same thing with teacher. This teacher has all these three characteristics with a special characteristic of its own, that is nothing but employee ID. Now next we'll see an example, that is example of online shopping. One example you can take either Flipkart and something. So let us see this. Now this example, it is written in more in detail. If you can, if you want, you can write a few attributes, not every attribute required. Okay, but the entities are required. Now we have online shopping portal. Now this online shopping portal has few categories and has few segments. Okay, now if I go to categories, then each category will have some name, and these each categories are again connected to some brands. Okay, and these brands will be having some products. So each category will be having some attributes. This each entity has some attributes with them. Let me take category, because online shopping portal will have some categories. Those categories had some brand in it. Now these brands can have more than one products. Okay, and if an a customer wants to buy, because online portal basically belongs to a customer, that is the relationship between customer and online shopping portal. Now this customer can have its username, first name, last name, customer ID, password, email ID, address, and so on. So what does customer does? It buys some products, and for buying some product, what it does? It does some payment. Now, if a customer buys some products, these products are added to its cart item. Okay. Now, once the cart item is added, what are the attributes in it? Basically, we see quantity, cart item ID, and what is the total cost. Now, once the customer has added the particular product in his cart item, what he does? He does the payment. Now, payment is, what is the payment ID, type, amount. After the payment, after this this payment is done for the cart. That is nothing but this cart is made up of cart item, and what is the total cost you are paying, and what is the card ID. So that is nothing but shopping portal online. And you have one more example where we'll see a university with entities, that is nothing but department, instructor, student, and course. Now what happens here? They have said a student is one entity, you have instructor, you have course. So what happens here? If a student enrolls in the course, okay, course which is offered by a particular university. So what happens here? There are few courses offering. Now courses offering depends upon course. That is why it is a weak entity. And this course offering is totally participated. Now one more point here. Whenever you have a weak entity, you also have a weak relationship. Okay, a weak relationship, that is nothing but double diamond. Whenever you have a weak entity that is represented in double rectangle, you also have a weak relationship. And whenever you have this particular weak entity and relationship, there will always be a total participation. Now student enrolls in the courses which are offered. Okay, and these courses which are offered is taught by some instructor. Okay, instructor teaches these courses. Okay, now student have some characteristics. First let us go with all the entities. Student, this has student ID, name, and some program. Course has some syllabus, course number, title, some credits, and some relationship, that is nothing but prerequisites of a course, or it's the main course. Then instructor, it has its ID, name, which department he's working in, what is the title of it. Okay, and they're connected. Now course offering, each student enrolls in the course which is offered, for what year, and what is the time, what is the section number, room, and semester. Okay, so that's all for today. So thank you.